Welcome, this is Mr. Dahlstrom's pre-AP Physics video about free fall or calculating free fall acceleration. The previous video basically went over the free fall notes, what that means, the kinematic equations, and some just other basics. With this worksheet, this video is talking about how to solve a couple of these problems. So I'm only going to solve two of them because that's as far as we got in class. I'm going to try to give you some strategies and all of that. So here we'll look. Go ahead and look at the first one. The first thing it says, the direction says you want to draw a picture, then write your variables as we always done, and then choose your equation. So drawing a picture is becoming more and more important because, as I stated in class, if we had a car that was, just say, moving horizontally, if you were driving a car and you suddenly were to hit the brake and it were to slow down, and it came to a stop, it wouldn't just start going back in the opposite direction with the brake on there. It was basically, it ended at that point. So you're either speeding up, you're slowing down. We never really did anything where it could be slowing down and then speeding up. You could definitely imagine this happening if we have an object that we're tossing up in the air. I toss it up in the air, it goes up, and then it comes back down again. So drawing a picture to see what's happening here. So I'll go ahead and draw my helicopter. It's an ongoing joke that I'm an excellent artist here, so maybe this will be my YouTube clip here. That's not horrible. Okay, there's my helicopter. May not be very aerodynamic. Don't worry about them not being any doors, but there's my helicopter because it says a bag is dropped from a hovering helicopter. When the bag has fallen 2 seconds, what is the bag's velocity and how far has the bag fallen? So we have this little bag here. And just indicating that it's being dropped. That's something important we'll talk about here in a second. And then it's going to be falling down. One thing I wanted to mention, actually, before we go back, I'm going to go back to this other worksheet real quick here and talk about some key words. So some key words for solving our problems here. First one is the word dropped, or released, or let go, or anything that's basically very similar to dropped, released, or let go. What that tells me, okay, it's not telling me necessarily a number. What that tells me is that if I have an object in my hand and I just suddenly drop it and then it starts to fall, what it's telling me is that my initial velocity in the y direction is 0 meters per second. So that's very helpful to have these key words because they may not have the numbers there, but if you see the word dropped, that means that the initial velocity is 0. It wasn't moving and now it's moving, so the initial. The other one that will come up in a later video here is the term max height, or greatest height, or how high does it go. Anything that's talking about as high as something goes at that point. If I were to throw an object up in the air and it were to go up and it would reach a point of its max height and then start coming down, there's something that we can say at that point. The thing we could say at that point is that we know something about the velocity, specifically what we're calling the final velocity. If you think about what max height means, that means that the ball is no longer moving up. It hasn't started yet moving down, so there's that point where it's basically not moving up or down, and if it's not moving, then it is 0 meters per second. So we have these two kind of phrases or words that help us. If it's dropped, initial velocity is 0. If it's max height, final velocity is 0. There's some other ones out there that we'll look at later, but this should get us enough to go here. So if we look back at number 1 here, and it says a bag is dropped from a hovering helicopter when the bag has fallen 2 seconds. So that dropped is going to be helpful. So I'm going to write my variables over here. Okay, delta y equals VIY, VFY. We'll go ahead and put a T here, and then we'll go ahead and do G at the bottom there. It doesn't matter the order we put them in. Okay, so we're going to go through it as I would ask in class. What is something that we know? Well, first of all, before we even start anything, we know, since we're assuming that we're on Earth, that this is negative 9.81 meters per second squared. And then I would ask in class, what else do we know? Now, some people might say, oh, 2 seconds. Okay, it's the time. It's falling for 2 seconds. That's one thing. But some other people say, sorry, that keyword here, dropped, is telling me something. It's telling me specifically that my initial velocity in the y direction is 0. So that's helpful to know. Because if you were to just scan through this, if you were what I'm calling a number hunter, you would see only 2 seconds over here, and you're like, how could I possibly do the problem? But because we recognize that dropped means something and we know the gravity, we now have enough. So we're going to try to find what's the final velocity first. And it's important to make a prediction of what we think this is going to be. Think about it. The bag is falling. When it has reached some point here along the way, it would make sense that there would be some number that would be negative, because negative means that it's going down. It wouldn't make sense if you were dropping this bag that after 2 seconds it's somewhere way up here. So it should be a negative number, and we have to make sure that that is the case. So we would eventually go to our equations here. Let me try to slide up the equations here, which equation we'd use. Oh, off to the side. We can do this. So we have gravity, we have time, we have initial velocity, and we're trying to solve for VFY. So in class I would say hold your hand up with the finger indicating which equation we use. If you look through this, that the equation would make most sense here would be the second equation. We're trying to solve for final velocity. We have VIY, we have gravity, we have time. So we're going to go ahead and choose that. So I'm going to go ahead and write the equation blank. VFY equals VIY plus GT. Okay. Go ahead and fill things in. So VFY equals VIY, which is 0 because we dropped it. Gravity is negative 9.81, and our time is 2 seconds. So we calculate that. VFY is negative 19.62 meters per second, and we box that when we ask ourselves, does that make sense? Well, our prediction here is that our final velocity should be a negative number, and so yes, it does make sense. So we'll go ahead and move on with that. The next part we're trying to find is how far has the bag fallen. So basically, what is delta y at this point? What we also learned from previous sections is now that we have more information, now that we have VFY, we can really use 3 of the 4 equations here. We could use that because we have initial and final time. We can't use this because it doesn't have delta y. We could use the third equation because we have everything here. We could use the fourth equation. So it doesn't matter which one of you. We already had a lesson where that was the case. I think most people will choose to pick the first equation, and that's the one I'm going to go ahead and use here. So delta y equals 1/2 VIY plus VFY times t. Try to separate that there. Delta y equals 1/2 times 0, quantity 0 plus negative 19.62, and that's all happening in 2 seconds. Now when you calculate this, you'll see that it's mainly a coincidence that exactly at 2 seconds this 1/2 in the equation, the 2 cancel out, and you get negative 19.62. This is not something that always happens here. This is just basically a coincidence that this number is the same as this number here. So if this were 3 seconds, that's obviously, if it were anything other than exactly 2 seconds, these would be different. So don't assume that these are the same. So that is basically a coincidence, or I don't know if that's necessarily definition of coincidence, but that's not always the case there. So I'm going to go ahead, I'm going to try to make shorter videos instead of having really, really long videos where people have to scroll through it and watch 20 or 30 or 40-minute videos. So I might, for the sake of this, either keep going with this video or slow it down. I'm going to try to keep them under 20 minutes. I think I can do that. I mean, we're going to look at number 2. But if I were doing this worksheet, I'm not going to do a whole entire lecture the same day. I think that would be pretty excessive. So I'm going to go ahead and move on to number 2. Number 2 is an interesting one because it's very, there's a lot of hidden stuff in there. And if you're, once again, if you're just a number hunter and you're scanning through here, you may say 10 and 78 and think, oh, I know what's going on here. But there's a lot of context here. So let's go ahead and read through it here. A stone is thrown downward with a speed of 10 meters per second from a height of 78. What is the stone's velocity when it hits the ground, and how long time does it take the stone to reach the ground? So here's an important lesson. We're going to kind of have a discussion here, but oh, there my lights went back on. That let's just say that this is some cliff here. Okay, there's your stone, and it's being thrown down. It's being thrown down with initial velocity, but also it is ending up. It's ending up down here. So if I were to call this 0 meters and I were to call this 78 meters, that's why we call height 78. That's a good enough picture for what we're doing. It's showing the difference. It's showing that it's not this scenario here. So what we have here is we have an object that's being thrown straight down instead of being thrown up and then coming down. Here's the 2 differences here. So we'll go ahead and write what we know here, or write out our variables. VIY, VFY, T, and then G. We are on Earth, so we'll go ahead and use negative 9.81 meters per second squared. But then we got to look carefully at what we're given here, because remember, we have to know the difference between speed and velocity. Speed is how fast you're going. Velocity is how fast you're going and in which direction. So it says it's thrown. That's important because thrown means it's not dropped. So it's thrown. It's thrown downward. Okay, that's a direction with a speed of 10. The speed is 10. The velocity, to indicate downward, would mean that it has to be negative 10. So basically, my speed says it's 10. But to indicate that it's downward, that needs to be negative 10. So that's the first kind of little clues that we have there. The other thing we have we're looking at is the height. Now here's where people usually get confused about this. So the height is 78 meters. We have to think about what delta y is. So I'm going to step forward back over here real quick. We have to realize what delta y is actually telling us here. It's y final minus y initial. And if we are dealing with something that is 78 meters, bring this up here, 78 meters, and this is 0 meters, and the object is ending up here on the ground at the end, then that means that the final position is 0 minus the initial position 78, so delta y in this case is negative 78. Now you can think about it mathematically like that, but I think an easier way is figuring out like, okay, it's moving 78 meters, but does the object ultimately end up below where it started or above where it started? Because a lot of people get confused. They may say, okay, I understand why that's negative 78. What about this scenario? What if this was 78 and this was 0, but instead of throwing it down, I threw it up and went way high and it came down here? A lot of people would say, oh, well, your initial velocity here would have to be something positive because you're throwing it upward, and so they would also think that the delta y was positive. But think about it. This object is ultimately landing 78 meters below where it started. So it's 78 meters below where it started. Because what would it look like if it ended up 78 meters above where it started? If it was 78 meters above, that basically like having a ball here and you're throwing it all the way up here, so now it's there. In this case, delta y would be positive 78. So it's not necessarily if it goes, if it goes way high. Even in the most extreme case here, where if we had something like this, and I were to throw this up, and this would go way high and come down, if the height of this little step here is 1 meter, because it ends up below where it started, delta y would be negative 1 meter, even though it had this huge path down here. So let's keep that in mind. We'll go back to what this problem says over here. And so the height is 78, but we're realizing that the stone is ultimately ending up at the bottom 78 meters below. So the distance is 78, but the displacement is that it's 78 meters below where it started. Okay? And we're trying to figure out the stone's velocity when it hits the ground. Here is another kind of misconception that people think. They see that, let me get another piece of paper here. They see that the stone is being thrown down, and they're thinking, okay, if I have a surface here and I throw an object and it hits the ground, that the moment it hits the ground it's not moving because it's not going down and it hasn't bounced up yet. But what this question is really asking is not how fast it is when it's on the ground, it's when it hits the ground. It's the process. It's the process of actually hitting the ground. So it's almost like the instantaneous velocity right at that point. Here is a reason why it's not 0. And people say, well, it should be 0. Here's kind of a scenario. If I were to throw the rock down or just drop the rock and it would be going 0 meters per second at the moment it hit the ground, that means that it wouldn't be moving. So here's the scenario. If that was the case, which it's not, you could be standing somewhere and somebody could have a bowling ball above your head and they could drop it on your head, and if in case it was 0 meters per second when it hit, that means it's not moving, that means it wouldn't hurt your head. Now obviously that doesn't make sense. The bowling ball is clearly going to make some kind of impact on your head, and so that's one of the kind of analogy reasons of why it's not 0. It is still moving. That's why things make dents into the ground, they are moving. So we have to realize that this is not 0 meters per second here. It is going to have some value. So We'll go over to our equation sheet and figure out what equation we are going to use here. Let me kind of line that up there. So we have delta y, we have VIY, we have gravity, and we're trying to figure out what VFY is here. So to kind of quickly go through this, we would use the fourth equation. One of the reasons is we don't know time, and if you look at the fourth equation, it's the only thing that doesn't have time in it. So the fourth equation is what we're going to use here. So don't trail off. Some of you may be like, oh, I know exactly what's going on. This is the really important part of these problems where a lot of mistakes happen when solving this, especially in terms of this VFY squared here. If we're thinking about this object as it's falling down, a good prediction for this is that VFY should be a negative number. I mean, it's going down, so that's what makes sense. So hold on here. I'm going to kind of rearrange some things and write it in a different way. Okay. So just taking the square root of everything, VIY is negative 10 squared plus 2 times negative 9.81 times negative 78. Now, if you had put positive 78 and tried to calculate this, you would get a square root of a negative number, which you can't have. We do not have imaginary numbers in this, okay? So that is one kind of flag part. If you get a square root of a negative number, something is wrong with your calculation. The other thing I talked about in class is this negative 10 squared. It's really weird that we have these calculators that are you know, sometimes over $100, and if you were to type negative 10 squared into your calculator, you think, oh, surely it's going to give you 100. Nope. In your calculator, it gives you negative 100 because for some reason it sees it as 10 squared times negative, and obviously that's not the answer. So we need to be aware, and that is why my negative 10 is within the parentheses. So I'll go ahead and calculate this. And we have to, there was a question that was asked by somebody in my first period, and it was a really good question, and I had said there's one time, you know, he's like, technically we take a square root, isn't a plus or minus? And I said, yes, there's really only one scenario, the problem where we're actually having to think whether it's positive or negative, and it's this problem, or one's similar to this. So if we calculate what this is, let me see where my key is right here, we are going to get plus or minus 40.38. Now I stated in class that basically for every problem we do, you pick the positive value. But for this one, we have to choose which one makes sense here. We're not going to go into depth why. Basically, positive could make sense and negative could make sense. Both of those are equally valid points, but for this specific problem, we know that VFY should be a negative number, so we are choosing negative to be our velocity. We're not suddenly just changing it to make it negative. It is a possibility, and we are choosing the negative value of that. Maybe in another lesson we'll go over how, where, you know, theoretically, where does the positive actually exist? Short answer, if you were to go backwards in time, and instead of this thing being thrown down, if you looked at it at another point as like it was a parabola here, it's negative 48.38 at this point. If you trace it backwards, if it were going up, it would be positive 40.38, and then at that same point down, it would be negative 40.38. But we're only looking at the last part, so that's why negative makes sense. So that is my answer. When we go into the second part, how long does it take the stone to reach the ground? Trying to keep this under 20 minutes here, reach on the ground. Now that we have more information, now that we have more information, I'm trying to solve for time. I'm going to go ahead and use the second equation. I think it's a lot easier. But we have to realize that negative 40.38 is the actual velocity. So when we're doing VFY equals VIY plus GT, we have to make sure that we don't put 40.38 here. We have to put negative 40.38 because that's what we want to find. We want to find what it is at negative 40.38 at time. Okay? VIY is negative 10. Gravity is negative 9.81. And then time. If I add 10 over here, sorry, I'm running out of room. I get negative 30.38 equals a negative 9.81 times time. And when you solve for that, the time comes out to 3.10 seconds, which makes sense because it's a positive time. We always have positive time here. Now, let's say that you made some kind of calculation or you had a brain fart and you somehow got a negative time here. What I see a common occurrence here is that if somebody gets a negative time, they like say, like, hey, the time is negative 10 seconds. They're like, oh, that can't possibly be right. And they're like, hey, I got a fix. There. No, you can't do that. Let me show you an example of why you can't just turn a negative time into positive and makes it right. Let's say, hypothetically, I know we're not looking at this problem, just going down below. Let's hypothetically take this equation and redo it. But let's show you what would happen if you accidentally put 40.38 there. There's negative 10, there's negative 9.1, and there's time. If I added 10 over, I would get 50.38 equals negative 9.81 times time. And here we're clearly, I think, what is this, like 5.14. Let me do the calculation real quick. We did it in class. 50.38 divided by 9.81. 5.14, yeah. So it comes out as negative 5.14. Now that's an issue. So some people say, hey, how do I fix this? And they just say positive. That's the right answer. But it's not the right answer. The right answer is 3.1 seconds, not 5.14. So kind of reflect over this, the big things that we talked about today. I'm going to end the video here shortly. I know it's a lot of chaos there, but you can organize it how you want. Pictures are very helpful. The whole idea about negative delta y's in terms of which way you're dropping, and then also this sort of calculation part of that. So this is what I did today in class. We'll have some more problems tomorrow. The assignment, which I'm assigning, I'll go ahead and put this up on Schoology here, is for you to do number 3, and then for you to do number 4, and then number 5 I'll do in a separate video in class. So I appreciate listening. I do suggest that you do subscribe. It's not for me, it's for making my videos more aware to the people that need it. So I appreciate it. I will be on another video. Thanks for listening.